Good morning, good afternoon, and good evening, wherever you are. My name is Dane, and I work in the electrical maintenance department. And welcome to part two, where we're trying to establish if our appliances, as they age and becomes older, do they burn more current, causing us to pay more on our electric bills. Because in this time, it is very expensive. Just like a car that needs to be MOT'd. When that car goes to its MOT, we will know if that car is road worthy to be on the road, or we need to give it some maintenance check. It is the same with our appliances. This is why a part test is also important. As our appliances ages, it deteriorates. And are we burning more power or current, adding more to our electric costs because of the deterioration of some of our appliances? Or are these appliances still within the recommended values of the manufacturers? We will take a look on the board and to see some of these values and try to determine what they mean. We have on the board a toaster, and we have a fan heater. We have 3 meters that we will be using to check to see if the appliance is still within the recommended values of what the manufacturers say they should be. We have a meter that measures the current, and we have 1 meter that measures the voltages. We want to see if the voltage and the current will remain stable while the appliance is in use, or it is more than what the manufacturer says. We also have a part tester. The part tester is to make sure the appliance is still usable and it is safe to use. Let's put this theory to the test. We can see that we're getting a voltage of roughly 244 thereabout. Let's switch the heater on and see if the voltage will still remain the same. Now the heater is on. It's on fan mode, but we want to put it on the heating mode. We have 2 settings. We will put it on the first setting that will give us some heat. And we look at the voltage to see if it remains the same. Now we have switched to the first element of the fan heater. The voltage has decreased a bit to 241, roughly thereabout. Let's put it back. As you can see, it's in the first settings of the heater. Let us put it back at fan mode and see if there's an increase in your voltage. We can see that it has increased a bit. Now it's back onto mode. Now it's back onto the first element. Let's switch it to the second element and see if the voltage still remains the same. We can see again there is a slight decrease in the voltage as the power increases. Now we need to see the amount of current that the fan heater is pulling. Remember, we're paying for the current, and we're still within the limit of the volt that the DNO allows us. Remember, they allows us a minimum and a maximum, and we're still in, and we're between the minimum and the maximum, so that is fine. But let us see the current, because that is what we'll be paying for really. Now this is the current that we're getting. We're getting 8.68 thereabout. We can round it off to 8.7 amperage that this fan is pulling when it is fully running. Now let us switch it back to the element 1 and see if there is a decrease in our current. Yes, we can see that there is a decrease in our current. So we know that this fan is working between the two elements. When we increase it to the two elements, it increases your current. That tells us that yes, you'll be paying more on your electric bill when it is in full flow. Let's put it back again on the second element. As you can see, it's on the second element, and as you can see, the current is then double times 2, and the voltage is still within the minimum and the maximum requirement of your DNO. Now we need to do the multiplication and to see if what the manufacturer says is true about their fan. The instruction will be on part of the fan. Let us see if we can find it and then do the multiplication of what we have here. I hope you can see the manufacturer's instruction. It says between 220 to 240 volts and a power of 1830 to 2200 watt will be taken to run this fan efficiently. Now let us do the calculation and see what we come up with. If it is within the manufacturer's instruction or it's out of the manufacturer's instruction. Let's take a look on the board. This is our calculation value. P stands for power, V for voltage, times the I for current. When we did our test, we got a value of 239 volts times 8.7 amps when the fan was running at its full strength. When we do the maths, we got a value of 2079 watts. The manufacturer power rating is between 1830 to 2200 watts. We can see that we're still within the manufacturer's rating, and we can say therefore that this fan is still running in an efficient manner. If it was out of the manufacturer's rating, then we could say that this fan is now costing us more on our electric bill. But for now, this is a new fan really, so it should be within the manufacturer's instructions. I hope that you find this bit of video useful and look out for more in the future. I thank you.